Okay, so we're going to talk about PDG setups for PyroSim. This is a very basic setup, but there's a lot of kind of key information in here, um, so it'll be useful for you. This setup was basically created from using the sparse fireball setup from the .pyro effect shelf. Um, I've modified a few things in the setup. The first thing is that using the quick setup, I used it to create a lopnet. And then inside the lopnet, I've changed a couple of things. The setup by default comes with this SOP import. I changed that to a volume lop. And the other thing that I changed was the Karma render settings. I'm rendering with XPU, but I changed the resolution and I changed the path trace samples, just reducing it so that the renders go faster. The quality won't be as good, but the purpose of these tutorials are kind of to teach you how PDG works. It's less about creating a beautiful pyrosim at the end. I'll leave that for you guys to kind of do yourselves. But understanding these workflows and being able to kind of render quickly will make explaining the setups better for you guys. And then, well, before I go, a few words about why I switched these guys out. The USD likes to read things off of disk. That's kind of its general kind of modus operandi. So when you're using a SOP import, you'll notice, by default here, there's this kind of message: layer imported for SOPs has no save path set. The SOP nodes layer will be output to a file path generated from its Houdini path. So basically what this is saying is like, hey, you're referring to something that's coming from, a SOP network that doesn't live on disk. So what I'm going to do is when you hit render, I'm going to write something to disk that I can refer to or USD can refer to. Rather than do that, um, I'm just using a volume operator to kind of query and use the volumes directly off of disk. So it's kind of better, cleaner way of working, particularly in the context of rendering volumes. So that's why I've swapped those two guys out as well. Okay, now we come to our PDG network. We have three different examples in here. We have this first example, which is a very basic setup, probably what you'd use to render to your render farm. We have a slightly modified version of the previous setup. This one, perhaps depending on your resources, what kind of machine you have, and how big the simulation is you're doing, this is something maybe set up for rendering on your local machine. This setup here is for wedging. If you wanted to wedge multiple sims with different kind of parameter settings, that's what this network addresses over here. So the other thing that you'll notice we have over here is we have our scheduler nodes. We have our local scheduler. All of the examples that I'm going to be showing you today are going to be taking advantage of the local scheduler because I'm working off my laptop and I work remotely. So I'm going to be taking advantage of the local scheduler, which just basically means using the machine that I'm working on. We also have a deadline scheduler node, so you can hook right into your render farm if your render farm's using deadline. We have a tractor scheduler, so if your studio uses tractor, you can take advantage of that. And we also have an HQ scheduler, which is the scheduler that Side Effects uses. It comes for free with Houdini, so it's maybe a good option for you guys to explore as well. So you have a bunch of different options. All these networks are going to work the same with whatever scheduler you choose. Obviously, if you're using something like Deadline, Tractor, or HQ, your jobs are going to get finished much quicker because you can run things in parallel. If you're using a local scheduler, you're limited to the resources you have on whatever machine you happen to be working on. All right, so that's a bit of an overview of the setup generally. I'm going to stop this video here, and then I'm going to jump into this setup in this first PDG setup in the next video.